I want to talk now about the next largest structure, which are the nebula. I mentioned them earlier that when astronomers first began to look at within our Milky Way galaxy, they found that there were regions of space that had high concentrations of gas and dust. And then eventually they began to see pinpoint sources of light, right, along the edges of the nebula. And they recognized that that can't be dust if you're seeing point sources. It must be stars. And so they began to recognize that some of these nebula were not gas and dust. They were other universes, billions of stars, hundreds of billions of stars that must be far away. However, not all the nebula were galaxies. There are still areas within our Milky Way that have high concentrations of gas and dust, and they move, they change, like the clouds. When I was a kid, I used to go to the theater, and when I was really bored, I would look up at the light and watch the cigarette smoke. I don't think you can smoke in theaters now, but the cigarette smoke would just sort of float in the air. If we had erasers with chalk dust, I could come to the into this light here, and I could hit it, and maybe my shirt will create it. No, not enough dust. You know what I'm talking about, though. If I had enough dust on me, you would see a cloud of glowing dust particles floating in the air. There you go. It's just starlight that's lighting it like a nightlight from within. There are two types of nebula. The first we're going to look at are what are called reflection nebula. And according to astronomers, it's regions of space where a star has exploded. This is the remnants of an exploded star. And then there's something called emission nebulas. And emission nebulas are believed to be nebulas that are in the process of exploding. So reflection is after they've exploded, and emission is in the process. So we're going to look at the exploded stars first. You see that bow shock? That means that they're moving around the star. That nebular material is collecting around the star. And so they are in motion, even though it's hard to tell just looking at them. They always look the same. But if you could look at 100 years, you would be able to see that it's changing. It's like when you look at clouds. And if you come back and look at them a few minutes later, an hour later, they change. And they may look like a giraffe now, but pretty soon they're going to look like a thumb, and then like a hippopotamus, and so on. Anyway, here's examples of some nebula. You can see there are some nebula that have regions that are so dense that it sort of blocks out the light. Here's a better example. So this is gas and dust, and this is where the dust is so thick that it's blocking out the light itself from the stars in the interior. Here's another nebula that's just really thick, like tar. But most nebulas are translucent. You can see the light passing through them, and they take all different kinds of shapes. And they really are non-representational. They're just amorphous material out in space, but our mind constantly wants to see stuff in it, right? And like Rorschach plots, or we want to see the images, and they name them many times because of that. Like this is called the Spooky Nebula. Spooky Nebula. You see the spooks? They're right here. So this is the Spooky Nebula. This is the Witch's Broom Nebula. Witch's Broom. This is the Witch Head Nebula. There's her chin. Here's her nose. And profile. This is called the Pelican Nebula and the North American Nebula. The nebula on the right is the Pelican Nebula. The nebula on the left is the North American Nebula. There's Florida, Gulf of Mexico, Yucatan, Canada. So this is North America, and there's the pelican snout. There's his head, maybe part of his wing. So you have to look carefully. Close up of the Pelican Nebula. But it's not really a pelican, it's just gas. It just happens to look like it. This is Thor's helmet. And Thor's really big right now. Have you ever seen images of the Norse god Thor? He has wings on either side of his helmet. So that's his helmet with the wings. Thor's Helmet Nebula. Not sure what this is called. It looks kind of like a horse head, but it's not the horse head nebula. This is a cat paw nebula. Cat paw. It kind of looks like a cat track, I'm guessing, out in space. Fox fur nebula. This is the tarantula nebula and the fly nebula. See the eyes, the tarantula? This is another shot of the tarantula nebula. This is inside the tarantula nebula. This is the jellyfish nebula and the heart nebula. This is the pencil nebula. It's hard to. This is the cone nebula. It's down here, and the cone nebula takes its name for this section at the bottom. I don't know if you can see it right here. Looks kind of like a cone. Very distinct feature. Cone nebula, pencil nebula. I'm not sure. I can't remember what this is. I think this may be the eagle nebula. Not sure. Trifid. This is the Trifid nebula. Has 3 dark bands. But again, an idea of the shapes and sizes, colors as the light passes through different gas molecules. This is the Lagoon Nebula. I guess that's the lagoon here. A lagoon is a body of water between a barrier island and the mainland. So I've never heard anyone explain what's so lagoony about the Lagoon Nebula, but I think it may be that dark streak there. It is very beautiful, though. It's one of my favorite in terms of the color. If God were an artist, what kind of artist would he be if you classified him? If you've had my faith and culture class, you might know the answer to this. Well, there's basically 2 types of art. There's representational art and non-representational art. Representational art is when you're trying to mimic something else. You're drawing a picture of something else. Non-representational art or abstract art is just pure creation. It's not trying to reproduce anything else. So you got 2 choices for God. God is an abstract artist, non-representational, or he's a representational artist. He's an abstract artist, and this is a perfect example, right? In that you've seen abstract art, right? Do you like it? I don't. It's all ugly. But you can do beautiful abstract art. God has just done it. It's non-representational, but it's also very, very beautiful. What does this represent? Just beauty. It's not a picture of anything. And so if you think about it, when God began creating, it was all abstract, right? Because if it wasn't abstract, that means there would have to be another God who made something, and our God is just trying to copy what the other God did. Or there's a universe that exists separate from our God, and he's just trying to duplicate it somehow. But I think we know that's not true, right? Therefore, we are living within God's abstract art. Isn't that a radical idea? When God just does whatever God does, and that becomes our reality, and here we are in the midst of it. And all art other than pure abstract art is just trying to copy things that God has done. I don't know, just something to think about, especially since it's so beautiful. And abstract art can be beautiful if it's God's. Eagle Nebula. I guess that's the eagle here, maybe. I'm not sure if I see a lot of these. This is one of the pillars. If it's right here, I think. That pillar inside of the Eagle Nebula is here. And these pillars inside the nebula are the size of our solar system. So we're dealing with very gigantic, it's humongous. These nebula, they're large structures. They're not small. They can't fit inside of solar systems. Matter of fact, what's lighting these nebula from inside, astronomers think it's probably stars formation. So stars are forming inside like eggs inside of a nest, and they're lighting up the nest, the night light. Yeah, this is inside the Eagle Nebula. It's one of the gas pillars. It just seems primordial, doesn't it? I don't know, something about the image. It just speaks of the beginning to me for some reason. You can see out at the very ends of these pillars, smaller pillars on top of the big pillars. It's pillars, right? A pillar of pillars. We've seen that nesting effect and hierarchical structure to nature. Okay, now I want to talk about colors. I like this nebula because you can see all the different colors, primary colors, right? Red, yellow, and blue, and they mix together in the light within nebula, and they can produce all kinds of gorgeous colors, yellows and pinks. Here's some yellow nebular material, blues. Almost infinite variety. And what I'm showing you is just a tiny fraction of the nebula that we've seen. Yeah, you can see the clusters of stars inside the nebula. It's like a T-Rex, doesn't it? This could be the T-Rex nebula. Just made that up. Everything I've told you so far, most everything, is associated. I may have missed a few. Like the heart nebulas, I'm not sure about the heart nebulas. But the others I'm pretty clear on. But the T-Rex nebula, I just made that up. This is inside of Orion, I think. Yeah. We've moved inside of Orion's nebula. Remember we talked about the constellation Orion? The 3 stars that make up the belt, and then there's 3 more stars below that are much smaller. Well, that central star in Orion's sword is not a star. It's this nebula, the Orion Nebula. And if you have a good pair of binoculars, you can see that. Get a good pair of binoculars, go out at night, find Orion's belt, find the sword, look at the center star in Orion's sword, and you'll see it looks like a cotton ball because it's not a star, it's this. Inside of Orion's nebula, there's another place that looks like a horse head sticking up right here, like a chess piece, a knight. And that's the Horsehead Nebula, which is inside of Orion. And sure, it looks like a horse head now, but give it a few hundred years, 1,000 years, it'll probably be the Unicorn Nebula. Yeah, this will stick out. Unicorn Nebula, maybe the Seahorse Nebula, Sea Monkey Nebula. I don't know. Yeah. Could be the Fetus Nebula. I'm not even sure if it looks that much like a horse when you get up close, does it? But that's what it's called, the Horse Nebula. Maybe it looked more like a horse before. Maybe the Snuffleupagus Nebula. Something out of Dr. Seuss. There's his ears, snout. I don't know. But it is moving very gradually like the clouds, because essentially it is clouds of dust. Anyway, that's Orion. Now, emission nebulas. All right, here's a galaxy, spiral galaxy. And you'll notice a star right here. You see how bright it is? The reason that star is so intensely bright is because it's exploding. It's a supernova. And occasionally you'll see those what was it? Can't remember the date. It's like the 11th century, 1054 I think it is. You guys heard the timeline. Help me out. Is it 1054? 1054, so that's the year that the church officially split. Do you know that? The Roman Catholic and the Greek Orthodox split in 1054. Some of the bishops of the Western Church went to meet with the patriarchs of the Eastern Church to give them their papers of excommunication to split the church, and they knocked on the door and the patriarchs wouldn't answer the door. And so that's the official. They wouldn't even answer the door. So that's the split that took place in 1054. And that's the same year that there was a supernova explosion, and you could see it with your eyes. Matter of fact, I've read that the way it looked is you went out one night and you saw the full moon up in the sky, and then you looked to your left and there was another full moon. 2 full moons in the night sky. One of them was a full moon, and the other was a supernova explosion. It was that big. And they thought it was a new star had formed And now they believe that it wasn't the formation of a star, but it was the explosion of a star. That's the idea.
How long would that last if you did see that?
From what I've read, it lasted at that magnitude for a few weeks, and then it gradually began to diminish. And over about a year, 6 months to a year's time, it diminished back down into a star. And they even plotted it in the star maps, and they called it a new star. But then gradually that diminished till it disappeared. And now when they look at that region of space where they plotted that new star, they see the Crab Nebula, which I'll show you in just a second. Anyway, this is another supernova, a star-going supernova there. And when you see it up close, you can actually see it looks like an explosion, doesn't it? And these emission nebulas, they call them, are believed to be the remnants of a star as it's in the process of exploding or just after it's exploded. It hasn't dispersed into a reflection-type nebula. And they take many different shapes. All of them seem to be explosive in nature. Some even look like, a mushroom cloud, like A-bombs going off. So it's not too hard to believe that that's a star exploding. Many of them have sort of binary symmetry to them, bilateral symmetry. That's because of the gravitational field that's causing the jets of material to go in different directions. This just shows photographs that were taken of these emission nebulas in a 2 to 3 year cycle. So you can see it's changing quite rapidly by astronomical standards. I think that may be called the Ant Nebula. The Ant Nebula. It's like a big ant. But you can see even though each of them are different, they still can be classified with the bilateral symmetry on each side. This is the Crab Nebula. When they look to that region of space where they plotted that new star in 1054, this is what they see. And so it's believed to be the exploded remnants of that star after the eruption, or the explosion. And so if you've read the manuscript, you know that if they saw the light in 1054, is that when it occurred? No, they're seeing, if it's 50,000 light years away, they're seeing an event that occurred 50,000 years before. It's just that 1054 is when the light finally reached the Earth. It's possible that star is long dissipated now, but we can never know because the fastest that information can travel is the speed of light. And the further that you look into space, the further into time that you see, because it takes time for light to travel.
I have a question.
Mm-hmm.
Does that have anything to say about the age of space?
Mm-hmm. Yeah, if someone were to believe that the Earth is 10,000 years old, like young Earth creationists, when they deal with the finite speed of light and the astronomical distances of space, then that can create somewhat of a dilemma for them. And there are two responses that I've read. One is to talk about something called Riemann space, which I don't understand. But I think it has something to do with the fact that in Riemann space, the light can travel at superluminal speeds and something like that. So that means it can get here really fast, like in a few thousand years, rather than 50,000 light years or whatever. But I just have to confess, I can't comprehend Riemann space. I know what Romulans are, but not Riemann. And I've tried several times. I just don't have the mathematical, the knowledge in physics to comprehend it. The other explanation is much more easy to understand, and that is that anytime God creates something, he's naturally going to create within a cycle because nature occurs in cycles. And so when God created the universe, he created that light already on its way. And so what that would mean is that star never really existed. The star that exploded in 1054, God just created the light out there in space on its way to us. And all of the information was encoded in it that there was a star there and it exploded. It's called the prochronic view. And you'll read about it. And the different ways of harmonizing science and scripture, it's one of the ways is God creating with the appearance of age or history, and that's the case. And he can do that. I mean, he's God. That's the way he wants to create. It's fine with me. People say, well, that makes him out to be kind of deceptive, doesn't it? Isn't that kind of deceptive of God to create light, a stream of light with information encoded in it when the source of that stream of light never existed? Isn't that kind of dishonest of God? Well, you know, that's assuming that we comprehend stuff, I guess. If he's God and he's creating, then he could do that, just like creating the star. I'm sure if it makes him any more dishonest, but you know, you'll hear those kind of arguments. I think the argument that really bothers me the most against the prochronic view is if you take it to its extreme. If God is like that and God can do that, then a philosopher or skeptic may ask you, how do you know God didn't create you 10 minutes ago with all of your memories and everything inside of your brain? And you think, well, what's the big deal? Well, the big deal is if God created the world 10 minutes ago with all this programmed into our brain, then that means there wasn't a cross. Jesus never lived, never died. And that's significant to Christianity because we're a historic religion. So that can be a problem, I guess. Hollywood's made a lot of movies about that. Implanted memories. Like you can go, if you don't want to go on vacation because it's too expensive, you can go and they can give you a memory of a vacation. You never went on the vacation, but they can implant a memory. And it's kind of like going on a vacation. You remember having a great time on your vacation, but you never went. Is that Total Recall? What was that? Is that Total Recall? And there's several, I think Vanilla Sky, there's several of movies where they're playing upon this implanted memory, and it's sort of like being God in doing that, creating realities that never really existed, just the information of them. But anyway, this is different images of the Crab Nebula. This particular image shows that there are waves radiating out from the center, so that means whatever that star, when that star exploded, you can still see the pressure waves moving through the nebula as like ripples on a pond. All right, these are just other types of emission nebulas, and there's many of them, and they're quite beautiful. As you can see, this is the Eskimo Nebula. I guess that's the fur collar. I never really understood the Eskimo. That's the best I can get. You know, the Eskimos have those big fur collars. That's what I'm thinking. Eskimo Nebula, remnants. This is the one I was speaking about before. It's called the Hourglass Nebula, but that looks like an eyeball looking at you. That's kind of creepy. And it is weird that, you know, you're looking at these nebulas and you're seeing something that looks very lifelike, and it happens to be an eye, right? Because it could have been like a nose. And if it was a nose, it wouldn't be as big a deal, because you can't really look at people with your nose. I guess God could be smelling us as God's nose. But God's eye is a little bit more creepy. So anyway, see all the varieties? We're moving into a type of emission nebula now called planetary nebulas. They call them planetary nebulas because when they were first discovered, they thought that they may be the early stages of planet formation around a star. This is the sort of the shell of debris that would eventually collapse into planets. Now they have pretty much given up on that. It's not collapsing, it's expanding in an explosion. But they still carry that misnomer of planetary nebulas. There's examples of them. In some cases they just look like big bubbles out in space. Usually the debris is centered in some way around it's called a neutron star, very dense star in the middle. And they take many different shapes. The Helix Nebula is probably the clearest planetary nebula. I'll show it in just a minute. But anyway, this is the shell of debris around the neutron star in the center.
Why do stars take so long to explode?
It depends upon how heavy they are in terms of how long they can last within their main sequence. And the heavier the star, the more rapidly they burn their fuel. It's sort of like cars. You know, you have a really heavy, big car, and it burns its fuel a lot faster. So it's counterintuitive, but larger stars actually have shorter lifespans than smaller stars. But you'll read all about that in the cosmology section more than you probably want to know. So we'll wait till we get to there. This is another planetary nebula. I call this the spirograph nebula. Did you ever have a spirograph? You put it the little wheels and you turn it and it draws all kinds of neat. So anyway, you can see the different forms of planetary nebulas. If you look carefully, you can see the shell of material in the middle. This is the Helix Nebula. This is probably the best example of a planetary nebula. You see that star right in the center? That's a neutron star. The core of the star is collapsed, and the outer shell is blown out into a ring. At least that's the scenario. And because that material is collapsing, it's become very, very dense. If you remember in high school when they showed you the diagram of the atom, and they drew it on the board, and you had protons and neutrons in the middle, then you had the rings around it. What they may not have told you is that that's not drawn to scale. That's a schematic. That's not, you think, well, that's what an atom looks like. If I could go down on an atomic scale, this is what I would see, protons, electron shells. No chemist believes that. That's just a schematic. The actual model of an atom would be something like this. Imagine I have a BB, a little tiny pearl in my hand that's only a few millimeters across. And I put that BB or that pearl in the middle of the 50-yard line of a football field. Okay? That's the nucleus. That's where all the mass is, that little tiny BB. I put it on the 50-yard line of the football field. That first electron shell is at the end zone. That's the first electron shell. And it has a massless particle called an electron in it. The second electron shell is about half a mile away. And the third electron shell is about 10 miles away. And so the electron shells include this vast amount of space, and the mass of the atom is actually in this tiny little BB. And that's what creates the mass of material, like the desk and the floor in this room and your bodies. And so what that means is that we're mostly empty space, right? Isn't that the conclusion? We're mostly empty space. Now imagine if we could take those little BBs off the 50-yard line that has all the mass of the atom and take a matchbox and fill it full of those BBs. That would be pretty dense. That's what they think is happening here with these neutron stars, is the collapse is so intense that it's crushing everything down into a very small object, and eventually it crushes the atoms themselves. All the electrons are crushed away, the electron shells, and the protons and neutrons actually stick together, all the nuclei that have all the mass. And so you have an object the size of the Earth, but it's made completely out of nuclei. And so you have an extremely dense object. For example, if you could go to that neutron star and you could collect a matchbox full of that material, it would weigh 200 tons because it's so dense. That's the kind of object that you see there in the middle, the neutron star. Planetary nebulas. This is an interesting nebula here. It looks like there's nebular material around it, but what's actually happening is there's a star in the middle, and it's putting off waves of light energy. And this wave of light energy is moving through the gas and dust that surrounds it. And so you're actually seeing portions of it lit from the inside out through time. I don't know, there's a sequence here of images. These two anyway. That's the same object. But it looks different because the light wave they're taken at different times. So it's a light wave that's moving out from it. Anyway, more emission nebulas.